What we're going to do today is review the organic chemistry that we've been going through this week and over the last couple of weeks when I've kind of spread this information out. What we're going to do today, I'd like you to start with question number 1, and let's answer that one, and we'll go through the answers on that, and I'm going to pause the recording. You can do the same. Okay, let's check it out. Okay, I see that we have a little split in the ranks here, and actually you might think that there's 2 possible answers, and indeed there are. Yeah. And so it could be letter A, which most of you guessed, and intelligent guessing, and some of you guessed C. Both of those are possibilities, okay? But I want you to stick with letter A as the possibility, and an extra credit point for anybody who thinks they can circle the longest chain that would emanate from letter A. Whoa, fast. Come on, Sam, get yourself a point or 2. Sam's going to show us how. Okay, Sam has correctly circled the longest chain. Very good. And so you get a stamp for that. Now stamp for, I know that. And I wanted to do the one that starts with letter A on this one. And I have a reason for that. If we started with letter C, and we came down and we circled these guys, instead of going off this direction, you're going to create a very difficult naming situation, because you're going to have this guy coming off right here that is not too nice to deal with as a substituent. So just to simplify things, I wanted to just stick with letter A. But you guys didn't do bad if you circled or if you indicated letter C. No big problem on that. So we've got the longest chain, and we know who carbon number 1 is. And now let's see who can name it. Okay, I just asked everybody a question as to whether this structure was an alkane, alkene, alkyne, alcohol, aldehyde, or ketone. And this is an alkane because it has no double bonds, no triple bonds, and no functional groups. The hydroxyl group isn't there, and there's no carboxyl groups. Okay, we just got a correct name up there with one minor exception. Okay, this guy, this little ethyl, should be before the dimethyl, because we alphabetize on the first name of the base name, not the prefix that indicates how many. Yes. What? The numbers. Sure, we can do that too. Let's put this guy where he belongs. So the ethyl is going to come back over here. Okay, the 6-ethyl. I know what you're talking about. I think. You want to know where the numbers go? Yeah. Okay, this guy's 1, right? 2, 3, 4, 5, 6, 8, 9, and 10. It's a little hard because it's up on the board, so I know that's a problem. Right, this guy right here looks like an ethyl on the end. You never have an ethyl on the end of anything, ever. Okay, this guy is just part of the main chain, not an ethyl group. No, you'd never count that as a substituent.
Yeah, what about the last 2? The ones that were left out, you don't count them.
Last 2?
Yeah, the ones that weren't part of the main chain. They just go on.
These 2?
Yeah.
No, these are in there. They're in the name. See, this is part of the dimethyl. This guy right here is part of the dimethyl. This guy, the ethyl. Yeah, that's this guy. See, ethyl's on 6. Okay. Solid. You see it. It takes a little while sometimes. Okay. How many carbons in the longest chain? I'd like you to answer number 1 first. That's your first question on this slide. Okay? First question. You might want to pause your tape now to be able to do this on your own and then see what happens. All right, looking at the answers that we have, your correct number should be 10, and 10 was letter C. So almost half the class got that. If you were looking at A, that was only 5 long, you got snookered, okay? Because this guy across here, if we go horizontal to the right from here, it looks like that's a main chain, but it's not. Remember, you have to count from every endpoint to find out where that longest chain is going to be. And the longest chain here is definitely 10. Now, let's find out who's carbon 1. And then lastly, we'll give someone a chance to circle the longest chain. Okay. Next step. Here, clear. Here. There we go. No, the first thing you have to do is, okay, we got B as the favorite, and indeed B is carbon number 1. So now, let's see if we can get someone to circle the longest chain. Good. Amelia has properly circled the longest chain, and that is 10. And now it's time to see if we can give it a name. We now see the correct name, and that tells you that the ethyl is on carbon number 4, and I'll circle that. And methyls, the 3,6-dimethyl means that we got a methyl on 6 and on 3, and then the 5-propyl, your propyl is sitting right here. And again, before you name anything in a quiz, you'd always want to circle your main chain and your substituents so that you are as clear as you can possibly be as to what the answer should be on the test. Right, primary, secondary, and tertiary. That is a strange thing that you've never seen before. Now, does anybody have a problem with all these guys being alcohols? Okay, what do we call the OH group? Hydroxyl. It's not hydroxide. That's where it's an ion, OH ion. These are not ions, okay? And so they don't act as ions. And when you put them in water, they don't dissolve. They don't come off of the main chain. They stay. So what I'm going to do is I'm going to go through this. I'm going to tell you what makes a primary, secondary, and tertiary, and then we will put down the numbers of all of each one of them separately as questions. So this guy is a primary. Now just think for a minute about what you're looking at, and let's see why that's different than a secondary. This guy is a secondary. Okay, I should be. Yeah, this guy was the first one I pointed to. That's a primary. This guy down here is a secondary. And a tertiary is sitting right here. Now, can anybody tell me what the common factor might be that makes these guys primary, secondary, or tertiary? Anybody want to take a guess? Yeah.
So is it different where it sits in the formula?
No, not where it sits in the formula. It's more, a little more sophisticated than that.
The carbon that's attached to, if it's only attached to the OH, then it's primary. If it's attached to the other carbon, that's secondary. And if it has 3 other attachments, then it's the same.
Okay. What Monet's saying is, if we look at this guy, this first one more carefully, the hydroxide is on a carbon that is only hooked to one other carbon. Okay? Now, in this second one right here, this carbon, where the hydroxide or the hydroxyl is hooked to 2 other carbons, here and here. Okay? And on the tertiary, the hydroxide is hooked to this carbon, and he is hooked to a carbon here, a carbon here, and a carbon here. Does that make sense?
Yeah.
Okay. All right. Let's instantly test ourselves on this and make sure we get it. And now the question that I'm going to pose to you is, I want you to put in the numbers in sequence. Please keep them in like 1, 2, 3, 4, 5, 6, 7 sequence. I want you to name or to include primaries only. Okay? Primaries only. Okay? The question was, why are the primaries primaries? One more time, I'm going to say it slightly differently this time. Number 2 is a primary because that hydroxide is on an end. And number 4 is a primary because the hydroxide's on the end. But the carbon he's hooked to can only be hooked to one other carbon, even if he's on the end. For instance, if we put another carbon here and another carbon here, now this guy is a tertiary. That's why it's not 5, yes. That's right. That's right. That's absolutely right. Now, next question is, I want you to give me all the tertiaries. Starting with number 1, think, is number 1 a tertiary? And if it is, you put in number 1 and keep going until you get all the numbers for all the tertiaries. The answers came out mostly for 1, 5, 6. Let's check it out. Number 1 is hooked. This carbon right here is hooked to this guy, and this guy. That makes it a tertiary. So the 1 was correct. 2 is not a tertiary. 3 is not a tertiary. 4 is not a tertiary. 5 is a tertiary because this carbon right here is hooked to 1, 2, 3 other carbons. Okay? And so 5 is also a tertiary. And 6, as we look at 6, there's the carbon that the hydroxide is hooked to, and he's hooked to 1, 2, 3 other carbons. Okay, so that is good. Excellent. Well done. Now, okay, we were supposed to find the secondary alcohols, and let's go through each of those and make sure that they're correct. Number 3, the secondary, it is a secondary, and it's hooked to, that carbon that's hooked to the hydroxide is hooked to 1, 2 other carbons. So that makes it secondary. And in 7, the carbon that has the hydroxyl group on it has 1, 2 carbons hooked to it, and so that's a secondary. I think you guys have it. All right, on this slide, who is the propane? A, B, C, or D? Oh, there you go. So the answer is good on letter A. Now, if you had B, C, or D, do I need to clear anything up for anyone? Now it's time to raise your hand. Cool. All right. All right. Your next question is, who is 1-propanol? Propanol. Okay, the answer came out in favor of letter D. Now, the OL ending, this OL says alcohol. Okay, and the OL, an alcohol has to have an OH group.
Wait, the functional group, what's the difference between BS here?
What?
BS is the same thing as alkynes.
That's the next question.
Oh, I didn't see that.
That's okay. All right. And we'll stop. Next question. Who is propine? And what makes him propine? We have correctly, well, the majority has correctly identified the propine, the YNE ending. YNE, just this much. That's what indicates a triple bond somewhere in the molecule. Okay? And why is it propane? Or Pine. What makes it propine? Propine. Three bonds, but why is it propine instead of butane?
Because it's 3 carbons.
3 carbons. Good. Okay. Great. 100% on this one. Okay, on this guy, we're looking for propene.
What's left?
What?
Basically, whatever is left.
If you can remember what the answer is. Yes. Well, how about that? Isn't that amazing? So, yeah. Let's go back and review just a little bit. Okay, I don't want you to forget about ene, ine. Okay, those two guys, those are not alkanes anymore. Okay, they're now going to be something a little bit different, aren't they? Okay, the alkanes have no double or triple bonds, but propane and propine all have both have double and triple bonds, double or triple bonds. There we go. And then our alcohol, that's not an alkane at all, but we still use the 3 to be propanol and give the alcohol name that way. All right, let's go on. And okay, what we're doing is figuring out how to name by using the IUPAC or the common names. And so what I want to do is give you a couple of examples here, and then we'll go on and do some more of this. But let's start with the guy at the very top. We'll call him number 1. This guy will be number 2, and this guy will be number 3. So in number 1, we can call that, first of all, by the IUPAC name. So what would it be called if it didn't have the double bond O on? Propane. It would be propane. So this has a double bond, and what is it, a ketone or an aldehyde? Ketone. Why is it a ketone? Because it's not on the end. The carbonyl group, okay, this is the carbonyl group, is not on the end. It's in the middle. Now, for this guy, on the IUPAC name, I call it propanone. Now, if it's propanone, we know that that the carbon that has the oxygen has to be in the middle, or it would be propanal, right?
Yeah.
So, just IUPAC name for that, propanone. All right, let's go to number 2. And what would we call that? Huh? Butanone. Butanone. And why is it but? 4. And why is it on? It's a ketone because it's not on the end. It's in the middle. Okay, good. And let's do IUPAC for number 3. What is it? Number 3, hexanone. Now, by the way, this is 2 butan. Number 2 is 2 butanone. So this guy would be what? Hexanone. 2 hexanone.
Wait, you count from left to third, right?
Remember, this guy determines who's carbon 1.
No.
So this has to be carbon 1. Now, if I move this guy over here, okay, now number 1 is here.
But then number 1, you can't tell which.
Yes, you can. Of course you can. If it's here as written, this guy has to be number 1.
No, number 1.
Oh, number 1. No, you can't tell. No. So that's why we can, and it doesn't matter if it's a propane and it's an a ketone. If it's a ketone, then that means it has to be there. Now, just a second. Common name, different, based on substituent names. Listen carefully. This is very different. Number 1, I would name methyl ketone. Methyl ketone. Yeah, you could, but it's usually methyl-methyl. You can be putting away your responders, but I want you to listen. In this second one, we would call it methyl-ethyl ketone. Right? Methyl-ethyl ketone, and this guy is methyl-butyl ketone. Okay? That's it, folks. Thank you. This recording's not done. We'll continue a little bit more after. Okay, in this slide, let's look at letter A, the top structure, and let's see what we would call that. See if you can name this guy on your own. Stop the recording and name it, and then restart and see what the answer is. Now you'll notice that I circled the longest chain, which is going to be starting, let's see, we count in from this end, and we go 1, 2, 3 until we hit those 2 methyl groups. If we start on this end, we go in 1, 2, 3, 4 before we hit the methyl groups. So this carbon will be number 1. And if that's number 1, then to name this, we would have, so properly named, we have 3,3-dimethylhexane. Now, in the next one, I'd like you to circle the longest chain. Actually, stop the recording and circle the longest chain, and then we'll go on from there. Okay, I've circled the longest chain now, and let's see who's got to be carbon number 1. If we start from this end, we go in 1, 2, the second carbon, the third carbon is where the hydroxyl group is. See, this guy determines who's carbon 1 now. If we start from this end, we go in 1, 2, 3, 4 before we get to hydroxyl. So this guy has to be carbon number 1. So it's 1, 2, 3, 4, 5, 6. And that's how we would number our carbons. Now what we need to do is figure out what our substituents are. The substituents are 2 methyl groups on carbon number 2. So that accounts for the 2,2-dimethyl. And now the only other substituent, it's not really a substituent, it's a functional group. And so the name of the longest chain has to be 6, so it's hex, and we leave the E off of the hexane name and make it an OL. So this becomes 2,2-dimethylhexanol, and that's how we would name an alcohol. Now let's look at letter C, and I'd like you to circle the longest chain that includes the double bonded O. And that's what we have. So you're looking at a 4-carbon compound. So this is going to be, what is it, a ketone or an aldehyde? It has to be one of the two, and it has to be one of those two because of this guy right here. So we look at that and we say, well, gosh, that's a carboxyl group, and the carboxyl group is sitting there at carbon number 2 because he's closest to the right end. So this carbon right here would be number 1, and this carbon here is number 4. So we can name him now. We only have one methyl group on there, so the methyl is on 3. So we'd say 3-methyl. And this is a ketone, so this would be called 3-methyl 2 butanone. B-U-T-A-N-O-N-E. The O-N-E is because of the hydroxyl group being in the middle, and the butan, which would normally be butane without it, the but comes because there's 4. And that is how we would name this little guy using IUPAC rules. However, this could also be named in a different way. And let's do that. We've got this little group of carbons right here could be considered an isopropyl. And so we would have methyl because of this guy, and then we would have isopropyl iso because this carbon right here is in the middle of a 3-carbon chain, or a 3-carbon substituent, which we would call propyl normally. But he's hooked on the middle carbon of that 3-carbon chain, and that makes him isopropyl. And so we've got methyl, isopropyl, and this would be ketone. What I referred to in a slide before as the common name, okay? That does not use the IUPAC name. So my first name over here was the IUPAC name. And now let's do this last guy. This is a fairly simple one. Let's go ahead and start out with the longest chain. So if you want to stop the recording, you can circle the longest chain first. Okay, did you circle it the way I did? I hope you did. That's our longest chain. We have 1, 2, 3, 4, 5 carbons in that chain. And there's no substituents the way it's written right now. And because this carboxyl group right here is on the end, that 5-carbon chain is going to be called pen. We leave off the E that we would normally name it with as a alkane, and then what we have to do is add on the Al ending, and the Al ending makes it a what? It's not a ketone anymore. What do we call that? We call it an aldehyde. Yes. So it's an aldehyde. So pentanal. And that's all we need to name that pentanal. Now, let's go ahead and change this a little bit, and let's put a substituent on this guy. Let's put a methyl right here. Now, this has to be carbon number 1 over here. So that methyl group is going to be on carbon number 3. So this would be a 3-methyl pentanal. And that's how we name those guys. Okay, this is the end of the recording. I hope that by watching this and listening carefully and thinking as you go, that you've gotten some very good background on how we name things in the IUPAC and the common names for the aldehydes and ketones. Mostly for the ketones is the little common names. And then I hope with these you kind of got an idea of, gosh, you're going to have to remember that the double and triple bonds go, a double bond becomes an ene, and a triple bond becomes an yne. And no doubles, no triples, no functional groups. A functional group would be this hydroxyl group. The carboxyl group is also a functional group. And so we've got functional groups that could make a difference. But with the functional groups and whatnot, you've got 3 different functional groups: the hydroxide, the aldehyde, and the ketone groups. And then we go on and we go back here, and we saw how to do primary, secondary, and tertiary alcohols. And now you should be able to name those all right. And here we found out longest chain, and we're back with guys that we call the alkanes, which we started with in organic chemistry when we first got going. And then this guy. I hope this has been helpful for you. Good luck if you're taking a test tomorrow.